Well, here we are, last lesson in chapter 7. And we are going to be looking at a couple new theorems about parallel lines in triangles and so forth. So, take a look at, we've got the side splitter theorem, the side splitter theorem, and the triangle angle bisector theorem. So the side splitter theorem is just like what it sounds like. If I have parallel lines in the triangle, then this segment here is proportional. That proportion equals this proportion. So then we'll be doing some cross multiplying with that stuff. Again, this on the corollary to the theorem, it's the same thing. If I have parallel lines, these parallel lines are here, then these two are proportional to these two. And then the triangle bisector theorem, if this line bisects, then I can make a proportion for this side and this side. Those are proportional. And then there's the triangle mid-segment theorem. And remember the trapezoid mid-segment? That mid-segment, when this was the same as this and this was the same as this. The same thing goes for the triangle mid-segment theorem. If we have this parallel line here, it cuts this in half and it cuts this in half. So now let's use the side splitter theorem. So we have to find y. So in order to set this one up, we are going to set this proportionate to this. So I'm going to set y proportionate to 12. And then I'm going to say this, because it's the same, in the same area as y. So I'm going to say 6 is to 10. Oh, I should do this. So 6 is to 10. So now we just do our cross multiplication. We get 10y and 72 divided by 10, and y equals 7.2. So then we step it up a notch, of course, and I notice that this will be proportionate to this one. So I'm going to say x over x plus 1.5. Then the bottom piece, then the top piece. 2.5 and 5. Okay, so now we just do a cross multiplication. 5x equals 2.5, parentheses, 1.5. Okay, so when we do that math, we end up with 5x equals 2.5x plus 3.75. Then I'm going to subtract 2.5x. So I get 2.5x equals 3.75 divided by 2.5. And I end up with x equals 1.5. Okay, so let's step it up another notch. X and x plus 6, that's easy enough. Over x plus 6. 9, oh, we don't have that one, but you can figure it out. 30 minus 9 is 21. So this piece right here is going to be 21. So we've got 9 over 21. Remember, I'm taking the small chunk and then the large chunk, the small chunk and the large chunk. You can do it the other way around too. You could put x plus 6 over x and just do it opposite, but I just choose the tau is the small chunk. So, okay, let's do our math. 21x equals 9 times the quantity of x plus 6. 21x equals 9x plus 54. We're going to take 9x away from both sides. End up with 12x equals 54, and x equals 4.5. Now we're going to use the converse to see if those two lines right here, are they parallel? So that means what we're going to do is we're going to see if those two proportions are equal. So I'm going to start with 12 to 28. The question is, does it equal 10 to 24? Well, let me reduce this. Let's see. I can go by 4s. So this is going to be 3. And 28 divided by 4 is 7. Is it equal to, let's see what this one is. I'm going to go by 2s. So I get 5 over 12. They're not equal. So this shows that they are, DE is not parallel to BC. Nope, not at all. So let's try this one. Oh, no, there's math we have to do here. 9 over 27. 9 over 27. But I don't know this. So I have to do some subtraction. I take 33.6 and subtract 25.2. And I end up with 8.4. Okay, so this is 8.4, and that's 25, so I'm going to do that. Does that equal 8.4 over 25.2? Okay, remember how to get rid of that decimal in the fraction. We're going to multiply both the top and the bottom by 10. 10 over 10. So that we can get the fraction out of there, I mean the decimal out of there. So we end up with 84 over 252. And that reduces down, actually, to 1/3. Now does 9 over 27 reduce down? Yes, we can go divide both the top and the bottom by 9, and we end up with 1/3. So actually, yes. I'll just put this over here. They are equal, so yes, these two lines are parallel. So now using the corollary for the slide splitter's theorem is very similar. In order to figure out x, I'm going to use this part of the drawing. So I'm going to say x over 30 equals, and I'm going to say 15 and 26. Okay, so when we do that, we end up with 26x equals 450. So we divide by 26, and we end up with x equals 17.3. So we know that that would go here. But now we have to figure out what y is. So I'm going to use this part of the drawing to figure out what y is. So again, I'm going to use 15 over 26. And 16.5 over y. And now cross multiplication, I end up with 15y equals, where am I, 429. Divide by 15, and y equals 28.6. So that's how you do the corollary. Okay, now this one looks pretty scary, doesn't it? In order to figure out x, I need to, oh boy. I'm going to have to set this up kind of weird, aren't I? Because I can't use this over here. So I'm going to have to use this part of the drawing in order to figure out what x is. All right, so 8x over 60 equals 5x over 3x oh, this looks like it's going to be really crazy, doesn't it? But wait, it's not. Here, look at this. These x's divide out. That's 1. So now it doesn't look as bad. Okay, now we can do this. All right, so we're going to do cross multiplication. I get 300 equals 24x, right? So if I divide this by 24, I end up with 12.5. Oops. So x is 12.5. Oh, so now I have to plug this back in. So 12.5 needs to be plugged in right here. And right here. So that I can do this proportion. So 8 times 12.5 is 100. And 5 times 12.5 is 62.5. Okay. So now let's see if we can get rid of some of this garbage here. I'm going to get rid of this, this, okay. Now we're going to set up another proportion so that we can figure out what y is. Using these two new numbers, this one and this one. All right. Okay, now we can do this. I've got y over 100. And I have 10 over 62.5. Okay, so now when I do the math, I end up with 62.5y equals 1,000. Divide 1,000 divided by 62.5. That comes out to 16. So we have x and we have y. Okay, now we've got the triangle angle bisector theorem. So we're going to be solving for x. I'm going to use this proportion first, so x over 24, and then I'm going to use this proportion here, so 30 over 40. Okay, to make this easy, I'm going to do this. Divide both sides by 10, so I end up with 3/4. So I got 4x equals 72. So then I can divide, and I end up with x equals 18. Again, I'm going to use this proportion here, 3.6 divided over 5 equals this proportion here, x over 8. All right. Okay. 5x equals 28.8. X equals 5.8. We got this baby. Okay. Well, we don't have this number here, but we can figure it out by 30 minus 18. And that's going to give us 12. So, how are we going to put this together? Because the bisector is this way, I need to use this proportion and this proportion. So, I've got x and 12 and 20 and 18. 18x equals 240. X equals 13.3. Okay, now we've got more than one x on the thing. Okay, so take a look. Let's see. I'm going to use this proportion and this proportion. Okay, see what we got. I'm going to say 3x over 3. So that means I need to say 8 over x minus 2. Okay, so, I can divide these 3's. That's a big one. Okay, so now I've got x times x minus 2 equals, well, 8 times 1 is 8. All right, so now I have to distribute. Oh, it's going to be factoring. x squared minus 2x equals 8. Well, take away 8 from both sides so I can get that all on one side, okay? So we've got x squared minus 2x minus 8 equals 0. Okay, so the first numbers are always going to be x. Okay, they have to multiply to this and sum to negative 2. So that would be 2 times 4, right? 2 times 4 is 8, so that means it's going to be a negative 4. Okay, so a negative 4 and positive 2. That'll give us a negative 8. Okay, so now we have to set those equal to 0. X minus 4 equals 0. X plus 2 equals 0. So x equals 4. X equals negative 2. We can't use a negative length, so x is 4. Last one. Okay, so this is the triangle mid-segment theorem from way up here. Where is that? From this one. So we're going to use that fact that we have parallel lines and we have the segments and so forth, and we're going to be able to figure out these lengths. So we're looking for length DE. Well, DE is this segment right here. Well, if it's a mid-segment, it's cut this and this in half. And if we look up here, we can tell that this segment is going to be half of 15, which is 7.5. So DE is 7.5. Okay, so if we look at DB, let's use a different color. DB right here is the same as this one, which is across from 9.2. So that right there is 9.2. Okay. So now we're looking at the degrees of that angle, the measure of angle FED. FED is this angle right here. Well, we have parallel lines here, so take a look at this. I'm going to extend the parallel lines. And I'm going to extend this transversal. And I'm going to look at this and say, okay, well, this one has to be A2. Because, how did I figure that out? Oh, yes, I did. No, I don't remember. But it is 82. And let's get Mrs. Gerard to explain that again to me. Thanks for listening and have a great weekend, you guys. We'll see you Monday with any questions.